Welcome to Ruminations. I am your host, Bobby Gill. Today, we are talking about one of my favorite topics, and I imagine it's one that you'll be excited to hear as well. We are digging deep into the science of soil health on grazing lands. In this episode, we will cover the latest research on carbon sequestration in arid and semi-arid rangelands. We'll go over what the different types of organic matter can tell us about carbon permanence. We go over a new framework for research that allows researchers to understand how the different dynamics of grazing management affect soil carbon accumulation. And we even dive in at the end a little bit into research that explores the mental models of holistic managers to understand not just what makes them tick, but why holistic management is such an effective framework for grazing planning, decision making, and more. And to walk us through all of this, today our guest is none other than the brilliant Dr. Paige Stanley from Colorado State University. Dr. Stanley is an interdisciplinary scientist dedicated to exploring grazing management and how it can sequester carbon in soils, mitigate climate change, and build more resilient rangeland ecosystems. With a bachelor's in biology and economics from Georgia College, a master's in animal science from Michigan State University, where she studied under Dr. Jason Roundtree, and a PhD in environmental science from UC Berkeley, Dr. Stanley brings a truly holistic perspective to her work, drawing on fields as diverse as soil biogeochemistry, rangeland ecology, agroecology, sociology, and political ecology. Her research focuses on the potential of regenerative grazing to increase soil carbon sequestration and improve rangeland function. Dr. Stanley is committed to advancing rigorous and innovative methods for measuring soil carbon, prioritizing real-world on-ranch studies over controlled grazing experiments. That's important. By doing so, she captures the nuances of regenerative grazing at scale and over time. This is a wonderful episode. It is detailed and nuanced. We, right out of the gate, get into the weeds, but hopefully we make this digestible for even those of you that are not deep in the literature. So even if you're not a soil science nerd, I think you'll get a lot out of this podcast. I know I certainly did. But without further ado, here is my conversation with Dr. Paige Stanley. But first, a word from our sponsors. This episode is brought to you by Savory's growing community of regenerating members, listeners like you who care about real solutions for our global grasslands. Over the past decade, the Savory Institute has helped restore more than 100 million acres through holistic planned grazing, creating productive and resilient landscapes where fertile soils lead to healthy food and thriving communities. But this kind of impact is only possible with support from people like you. For just $10 a month, less than the cost of lunch, your support can help restore nearly 400 acres of land every single year. And as a regenerating member, you'll join our global community of over 600 like-minded people committed to making real change where it matters the most. You'll get access to Savory's private online network, a free holistic management online course, discounts from partner brands, and even opportunities to connect with Alan Savory. Signing up is fast, easy, and it makes a real impact. Just visit savory.global/member, that's savory.global/member, and start making an impact today. Dr. Paige Stanley, welcome to the Ruminations podcast.
Yeah, thanks for having me, Bobby. I'm excited to do it.
Yeah. So, we actually had to reschedule this podcast recording from a few weeks back. You were under the weather. I think we've all been hit by the flu recently, so glad to see you're feeling better. But I'm actually kind of glad we had to reschedule because just last week, I think it was, a new paper of yours was published. So why don't you tell us about that?
Yeah, absolutely. That paper was such a long time coming. That was actually the first experiment that I designed as part of my PhD dissertation. So I started that field work, and it actually has an interesting backstory. I started that field work during COVID. It was 2020, and I had been kind of building out that work for a while, and then the time came to finally get out on the ground and collect these soil samples from all these ranches that I'd been working with. COVID hit, everything shut down. I still went and collected the samples because I was going to be out in the middle of nowhere with no one except one other student. And so it was just an interesting time to be doing that kind of work. And I wound up doing all the lab work by myself in the lab, which was, one person at a time. But it finally came out last week after a really long, grueling process. And the paper was intended to kind of asked the question about the efficacy of amp grazing in California, because up until, well, still now, even most of our understanding in the US on the effects of amp grazing have come from the Southeast or studies in the Southeast, which have a really unique climate, land use history, kind of grazing potential. But most grazing land is actually in the Western US, and they're more characteristic like semi-arid and arid rangelands, which pose unique challenges to carbon accrual, even in the best case scenario of grazing management. So I wanted to get started on trying to open up the hood on how amp grazing works in a system like that. And so I worked with 8 ranchers for that work. I was limited in terms of how long I could be doing this kind of experiment because I was in my PhD program. So rather than measuring soil carbon over time, which is the gold standard for something like soil carbon, I recruited paired ranchers. So these are ranchers that one side or one neighbor is an amp grazer, and on the other side, they're more traditional, conventional grazing, which in California is like a low rotation system, often between 3 or 4 pastures. Um, and I just collected a ton of soil samples to try and understand if there were any differences that we could attribute to grazing in some shape, form, or fashion. And so to do that, we tried to control for things like soil texture, land use history, plant communities, slope aspect, the whole nine. Um, and what we found was we actually were able to detect some differences in soil carbon between these ranch pairs. And if we were to think about them all together as a group, there was an effect of amp grazing on soil carbon. So, amp ranchers, as part of that study, did have greater soil carbon than their neighbors on average. And then there were some also site-wise differences. So not all pairs had significant differences in their soil carbon stocks, but some did. And so this was, I think, my first attempt at trying to understand what drives these kind of really specific site-wise interactions. And what I'm thinking might be the case, which is going to start driving my work moving forward, is potentially nitrogen dynamics. I think there's something really interesting happening with amp grazing and nitrogen in a way that makes it more susceptible to accruing soil carbon, especially in that really persistent fraction mineral associated organic matter, which is a really nitrogen reliant fraction of soil carbon. And that could be a number of things. It could be, by grouping animals at higher stock densities, for example, you get a better distribution of manure deposition. Um, that's kind of my working hypothesis now. And so I've got a USDA grant kind of waiting in the wings to hopefully fund that work.
Can you speak a little more to that carbon nitrogen ratio piece? I know we're right out of the gate. We're diving deep into the weeds here, so
Yeah.
apologies to the listener for that. But hopefully we can make this digestible for folks that perhaps aren't as steeped into this as you are. But
Mhm.
my understanding is that low carbon to nitrogen ratios allow for greater efficiency of carbon sequestration. Is that correct? And if so, can you kind of explain the mechanism behind that?
Yeah, that's absolutely correct, especially for that kind of stable fraction of organic matter, that malm. So
Mhm.
we have this kind of current understanding of how soil carbon comes to be. Like, how does it accrue? What are the pathways and mechanisms that it gets there? And we can think about soil carbon as being in 2 different fractions that are biologically distinct. They get there along different mechanisms. One is that mineral associated organic matter, and the other is something we call particulate organic matter. Particulate organic matter actually forms from the higher C to N ratio inputs to soil. So things like partially decomposed plants, for example. So, like plant litter or sloughed off roots. These are things that contribute carbon and nitrogen to the soil, but in a significantly higher carbon to nitrogen ratio. And you can think of carbon to nitrogen ratio as like, um, let's see, how calorically dense is your dinner? Is it pizza or is it salad? Um, and things that are higher C to N ratio are more like salad, and things that are lower C to N ratio are more like pizza. You're going to gain weight much more quickly eating a bunch of pizza than you are a bunch of salad. And that's kind of how I think of malm and palm. Where malm, that more stable form of organic matter, so this is carbon that's like stuck to soil mineral surfaces, which
Hmm.
makes it inaccessible to things that would otherwise use up that carbon and re-respire it into the atmosphere. And that form of carbon comes from things like my dead microbes, microbial necromass, or root exudates, things that are really simple but have lots of nitrogen compared to the amount of carbon. And that makes them much more easily digestible by microbes. And then those microbes eventually die and sorb onto mineral surfaces. And so that's one really direct pathway. And things that just have more nitrogen in them are more efficient at forming carbon along that pathway, which also makes it more persistent in the soil for a longer period of time.
So the mineral associated organic matter, this is the stuff that is attached to minerals. You'll get this often at the deeper depths where you have deeper perennial roots, but not exclusively at deeper depths. You can also have it
Right.
at higher depths.
Mhm.
Particulate organic matter, this is coming from decomposing plant litter and other sort of stuff that's found almost exclusively in the upper layers, like the top 10 centimeters, 30 centimeters. Would that be correct? Or like in greater proportion at
In
those upper?
greater proportion, yes, certainly. We are learning a bit more about palm formation and stabilization at depth.
Hmm.
So your explanation is completely spot on. The only addition I would make is that we're learning that deeper perennial roots, when the roots themselves slough off, especially at depth where there's not a lot of oxygen, there's not a lot of microbial activity, that actually helps form a more stable form of palm because it's happening at deeper depths. So we're learning more about how we can accumulate palm at depth as a more stable pool than we would think about it in the surface. And also, something I'll add is in the surface, you can also partially stabilized palm in soil aggregates. So, for example, if you are encouraging a lot of root exudation or rhizodeposition or a lot of microbial activity, both of those things form kind of sticky compounds in the soil, which helps form soil aggregates, which can occlude palm and partially protect it for, on a decadal time frame.
Hmm. I've heard a description before of the difference between POM and MALM. And this is the first time I've ever actually said those out loud. In my mind, I use POM and MAOM. But I've heard it described as POM being more of the checking account in the soil
Yep.
because there's going to be a quicker turnover. That carbon is going to be cycling more often. And then
Hmm.
the MALM being that, I mean, I guess permanent isn't the right terminology to use, but the more stable form of carbon. That's going to be more like your savings account. You're not going to tap into it as often. It's not going to cycle as often. And well, I guess first, is that an accurate description of those two different organic matter fractions?
It is, I think. I mean, as a soil scientist, there's always nuance, right? Like I could get into exchangeable malm and more stable palm and all of that, but in a very general sense, that's absolutely right.
Mhm. And now, how does that then affect, I'm going back to some of the things that we constantly hear in the regenerative grazing space, and um, there are often discussions about carbon permanence and saturation points,
Right.
and discussions over academic debates of, well, carbon reaches a saturation point and therefore it isn't good in the long term. There's all sorts of reasons that people try to discredit this form of grazing because
Mhm.
of different angles that they try to take. How do these different organic matter fractions, POM and MALM, affect carbon saturation? Does one reach a saturation point and the other does not? Is there some nuance there?
Yeah, absolutely. I think you're right in that a lot of people are, or I've heard some similar sentiments at least that like, why are we, investing all of this time and effort into things like amp grazing if eventually soil carbon will saturate? Like, why is that worthwhile?
Hmm.
I tend to push back on that, or I definitely push back on that because I mean, theoretically, yes, soils do have a saturation point, but it only really applies to that mineral associated organic matter fraction, that MALM, because MALM is reliant on mineral surfaces, so like silt and clay for things to stick to. soils have a finite amount of that, and that is dependent on your soil texture. So, for example, sandier soils will have a lower, quote unquote, saturation point because they have less available mineral surfaces compared to a more loamy or a clayey soil. And so, and I'm going to circle back to that because there's
Mhm.
one more, I think, layer of nuance worth exploring. Whereas palm, there is no saturation point that we can at least understand or measure because it's just more of that checking account. There isn't an upper limit or threshold to its accrual because it's a more dynamic fraction. It's turning over all the time in soils, and it's not reliant on something to build. And so you can build palm up to infinity.
Mhm.
Um, but there is this, hypothetical kind of, asymptotic limit to something like malm. Now, there are some, I think, newer developments in terms of how we've come to understand malm that maybe challenge our previous assumptions about soil saturation or, you know, accrual capacity or something like that. And that's because formerly we were thinking of malm as kind of like a shelf system. So for like every mineral surface, you can fit one malm, for example, and you might be able to put another form of or another kind of organic matter here, and you're just filling in the shelves like that. What we've come to understand is you can actually stack malm on top of one another. The
Mhm.
further away you get from a mineral surface, maybe the less it acts like malm. So it might be more part of that exchangeable malm that I kind of alluded to earlier. But there might not be like a hard and fast cap on how much malm you can actually accrue. Now, that's like something we can debate in the science all till kingdom come, which we tend to do. But what I like to tell people is that even malm has a level of dynamism to it, and so I don't actually ever I've never approached a soil or measured malm from a soil that I think is like at its saturation point, for example. Especially from grazing, soil carbon accrual can be very low and very slow. And most soils, especially grazing land soils, are really, really far away from that potential cap or potential maximum. These soils have been mismanaged, developed, overgrazed, what have you, for thousands of years. They've lost so much soil carbon that it's really unlikely that we're going to reach even a hypothetical maximum anytime soon, irrespective of how we do or do not understand how malm saturates. So I think that's what I tend to push back on is that, like, yes, hypothetically it exists, but we're so far away from that being something we need to consider in the short term that I don't necessarily think it's worth at least quelling really well-intentioned efforts for grazing and soil carbon accrual.
Mhm. In terms of saturation, there's another talking point that I hear sometimes where um, the argument is even if soil could reach a saturation point through optimal grazing, there is additional layers of soil that are being built on top. And so the hype, say the existing amount of soil mass that you're looking at reaches a soil saturation point or a carbon saturation point, you're still building new layers on top of that, even at small amounts. And so that the accrual can still happen in those newer layers. Is there any truth or to that at all?
Unfortunately, no.
Okay.
I hear that a lot. And I think what I think is happening is that I hear that most often from ranchers that I work with. And what I think is happening is that potentially through better grazing, through amp grazing, they're noticing a fluffier topsoil. And that's not necessarily, it's actually almost certainly not soil creation or formation. Soil formation is something that takes hundreds to thousands to tens of thousands of years. And that's because it's the combined effect of organic matter deposition. So things like, manure and plant decomposition combined with parent material weathering. And those things together are soil formation. So that's why you get soils that have silt, sand, and clay in addition to organic carbon that we can measure. That comes from those two different kinds of inputs. The stuff that's happening on the surface is so when you accrue soil organic carbon or you increase your soil carbon stock through some management practice, you almost always reduce your bulk density unless you're compacting the soil at the same time, which is in grazing actually more uncommon than people realize. So, more organic matter means fluffier soil, means reduced bulk density. And so it's just the same amount of soil with more organic carbon taking up more space, is
Hmm.
what I think ranchers are noticing.
Interesting. So because of the root exudates or the increased porosity of that soil because of the channels from the roots and the rhizosphere and all of that and other aspects, the soil, like the actual volume of the soil is increasing. And so that could be what's being seen there.
That's exactly correct. And that's actually been something that I've really tried to pioneer in the range soil science community is ways to correct for that and the ways that we measure soil carbon. Because if you're not thinking about that, you can actually completely botch your soil carbon measurements, especially over time. Because exact for the reason you just said, part of what we need in order to calculate carbon stocks is volume. But if the same amount of soil is now taking up a different amount of volume,
Hmm.
you're actually not even measuring the same amount of soil at time one and time two. And there's a way to correct for that through something called equivalent soil mass.
That's exactly what I was just going to ask. So instead of bulk density, you do the equivalent soil mass.
Yeah, and it's still kind of bulk density. It's just thinking about it in a very different way to account for soil in terms of how much it weighs versus how much it takes up in terms of depth.
Hmm. Gotcha.
Mhm. Yep.
Um, Another part, as we're talking about soil physical components, I saw one of the sites in this study, site one, didn't show any statistical difference in soil organic matter, and you hypothesized that it could be due to the high clay content of the
Yeah.
soil. So, is soil texture a limiting factor for soil carbon sequestration?
Absolutely. It's one of those master um, kind of it's a something that creates master end caps on soil carbon accrual and loss.
Mhm.
So at that site, that was a really tough find for me because that is a rancher that is so near and dear to my heart, and they've been out there doing the thing for decades, and that was the longest standing, AMP or regeneratively grazed ranch in the study. And so
Mhm.
to find no difference was tough, but I do think there is something to this soil texture thing, especially at that site. So those soils they belong to a soil order called vertisol.
Mhm.
Vertisol soils are just a pain from start to finish. Like if I could never sample another vertisol, I wouldn't. So these are soils that they undergo shrink swell cycles depending on how wet they are.
Okay.
So they're super high in clay, and for example, when they get really dry, you might notice visible cracks or fissures on the top. That's a vertisol. And so what happens is, as especially in California, which is a xeric climate, we have a very or they have a very wet and a very dry season. When it gets
Mhm.
very dry, the soil cracks, organic matter, plant litter falls into the crack. So there's a bit of mixing that is
Mm.
not typical of most soils.
Okay.
Um, and when it's really wet, those cracks close and they almost become anoxic. They're so clay and so dense that it's the oxygen, the lack of oxygen really limits things like microbial activity, sometimes even plant growth. So I think it's just a challenging soil texture in general. And there are other ways too, beyond just that soil texture, that texture plays a really important factor here. So for example, really sandy soils are another kind of end of the extreme that I've seen be a challenge for folks because it makes it really difficult to accumulate malm because there isn't much mineral surface. It also makes it almost impossible to aggregate because they're so coarsely textured. Like think about the level of stickiness you would need to get beach sand to stick to itself. Um, so, there are challenges along the entire gradient of soil texture, but super clay soils in the form of those vertisols that I mentioned and super sandy soils are kind of the two ends of the extreme where I see the most challenges.
Mm. And these vertisols that you're discussing, where the cracks appear in the soil, Is this are, are these types of soils that you're going to find in more brittle landscapes? My understanding is that this paper, what makes it unique is that it's specifically looking at California rangelands, which are arid and semi-arid. And most
Mhm.
of the grazing soil carbon research that is out there is done in more temperate and subtropical environments where there is year-round available moisture. In holistic management terms, we would call that non-brittle. And
Mhm.
so, you've basically gone and studied an entirely different type of weather pattern that affects the growth patterns. There's a dormant season where plants are not growing, that affects the dynamics. So, yeah, speak to that a little bit.
Yeah, yeah, absolutely. I mean, vertisols exist all over the US, but they're more rare and they are more common in the West. So that is absolutely true. I think the other in addition to the, like, unique climate of these ranches that I studied in California, so, the really distinct wet and dry seasons rather than just the temperature differences among seasons
Mhm.
is, the plant communities and the way that they've evolved over time in California. They are almost now entirely annual dominated. So that they are dominated by invasive annual grasses that have been there now for so long that they're considered naturalized.
Mm.
So, in addition to the challenge of having um, your precipitation come in a really limited window and then have the rest of the year be very, very dry, which is the case in California, you also have the additional challenge of having plants that don't necessarily respond to rest or aren't going to really regrow the next year because they just make new ones of themselves.
Yeah.
So their kind of energy allocation strategy for annuals makes it also really difficult to accumulate soil carbon because they don't invest in the same kind of root structures that perennial grasses do. Now there are other ways that I've seen ranchers really capitalize on annual grasses. Because they can grow so quickly and produce so much biomass, for example, there still are plenty of opportunity for to optimize grazing for carbon accrual in those kinds of plant communities, but they say they certainly don't have as much opportunity as like perennial grass dominated systems.
Hmm. And is another component of that just the depth at which perennial roots go down?
Yeah, absolutely. So, site 3 in this paper that we're talking about, I think, is a really good example of that. So, this is a site that had been tilled something like 12 years prior to me getting out there, and I didn't know that at the time.
Right.
And when I was looking at the results, I was like, man, something is really weird here. Like the AMP ranch has more carbon in the surface than the neighboring ranch, but the neighboring place has more carbon at depth. Like, what's going on? So that's when I figured out this history of tillage. And I think what's happened is that upon tillage, a lot of that surface soil carbon was lost. And you can see that in the lower amount of soil carbon on the AMP side. But over the 12 years, that rancher has really invested in AMP grazing and still managed to accumulate soil carbon in the surface, even with an annual plant dominated system. So I think
Mm.
that's really indicative of like the potential, but your benefit might be more toward the top for sure.
Interesting. Um, I wanted to do a quick aside, just because we've been saying amp grazing a lot, and
Mhm.
being with Savory Institute, we teach holistic management and holistic plant grazing. I noticed in the paper that there are direct quotes from the ranchers that you studied, and these ranchers indicate that they are managing holistically. They practice holistic
Mhm.
plant grazing. They've gone through holistic management trainings, but the term adaptive multi-paddock grazing is used in the literature. Can you speak to why, in academics, that term is used compared to the terminology that the ranchers themselves use or identify their practices with?
Yeah, absolutely. So AMP grazing, I think the first I recall seeing it in the literature was a Richard Teague paper back in the early 2000s.
Hmm.
And I can't speak to maybe why he chose to start using that term, but the way that I think about grazing terminology in my own work is it's informed by a couple of things, and I try to be really careful about semantics and grazing because it matters a lot to me. And I also it's kind of an ick amongst other researchers when I see them use things that I know aren't well thought out.
Yeah.
So, amp grazing I tend to use in a research setting because it doesn't imply that all ranchers using that grazing strategy have undergone holistic management training. Now, many of them have, and in
Hmm.
this case, all of them had. But I use it as a more general term to the grazing approach versus in the sister study that came out actually before this amp grazing paper. I have all of these ranchers and their full interviews, and I kind of coded emergent themes from these. And there I use a little bit of a different term, which is I actually don't even remember now. It's like AMP HM or
Amp
something.
HM, I think, or HM amp. It's the two of them
Yeah,
combined.
right. And so what I tried to do there is explicitly marry this like um, operationalization of adaptive multi-paddock grazing that is, short grazing duration, very fast rotations, high stock densities, lots of rest, married to the decision making framework that comes from holistic management, which is informed by all the other things, right? The other modules,
Hmm.
finances, social, all the things. And it's really the marriage of the decision making with the way it turns out in their grazing management that is the sweet spot, I think. And that's what I try to talk about in that social science paper. Because this paper was entirely biophysical, um, I used AMP as a more umbrella term just to refer to the grazing management and less about the decision making framework that informed the grazing management, just because I talk about it explicitly in the other paper. And I've used a couple of other terms in my work. For example, in the Ruminating on Soil Carbon paper, I use optimal
Hmm.
grazing for a really strategic reason. And that's because I wanted that paper to be more about the mechanisms and pathways associated with that framework that we built. So, trying to conceptualize the ways in which grazing influences things that we can see with our eyes, that ranchers can see with their eyes, all the ecosystem elements that we outlined in that paper, and how those impact downstream pathways of soil carbon accrual. And I wanted that to happen outside of the grazing jargon and debate. And so I tried to use very agnostic terms in that paper so as not to suggest to anyone that it needs, for example, to be AMP grazing, even though I do obviously think that there is something to AMP grazing holistic management. I wanted that paper to, I wanted the merit to be more about the framework and less about the terminology.
Yeah. Let's actually get into that paper because
Mhm.
that paper, I think, has certainly made its rounds. When you released that one last year, everyone was talking about it. Um, the paper is called Ruminating on Soil Carbon, Applying Current Understanding to Inform Grazing Management. And just a note to listeners, we'll put links to all these papers that we're discussing in the show notes and here beneath the video if you're watching on YouTube. So we'll have the links to all of these so you can go and look at them. So this ruminating on soil carbon paper, it wasn't a study that was publishing data, but you were creating a new conceptual framework that basically lays out a better way for how to study the different dynamics between grazing and the what were the terms? The eco physiology elements um, uh, in grazing lands. So, why was it important to publish a new framework that goes over all these different drivers and dynamics of soil carbon accumulation?
Yeah, that's a good question. I think so this paper was like my brain baby of my last decade of work with ranchers all over and talking to them, having conversations with them across dinner tables and in trucks, on the phone, over Facebook Messenger, and also thinking about like my applied soil science. And I think over that decade, I've just been increasingly frustrated with the lack of um, consistency in the research, and in fact, a lot of the utility of the papers that we have published, I think, are just really moot. And for reasons like most studies, for example, will study outcomes on soil carbon or plant communities based on grazing that makes no sense to me. and makes no sense to ranchers. Like, what is high intensity grazing? What is low intensity grazing? These are like grazing systems that have no real grounding in real life in any ecoregion that I've worked in. And so that's one thing. And the other is, or I guess the what prompted this entire body of work was, this was, oh gosh, 2 or 3 years ago at Society for Range Management in Boise, Idaho.
Mhm.
So SRM historically is a conference that isn't entirely associated with soil carbon. That's not a central focal point, but it's gained popularity over the years at that conference. And a couple of years ago, I was there, and there was a full soil carbon market panel that included some producers that were involved in the carbon market and lots of the companies involved in the carbon market. And I was just hearing them promise the moon to these folks in this panel. And me and my colleagues are kind of looking at each other like, what are they talking about? Like, those data don't exist. I know they don't exist. And so the things that they're saying are just on their face untrue. And I kind of left that thinking, like, what can we do to synthesize what we do know and also highlight the gaps in understanding that I think really just need to be called out at this point? Like, we can't keep letting these major, I think, issues in research fly when it comes to grazing. And a lot of that too, and I point this out in the paper, I think is just like scientists aren't talking to ranchers, maybe. It seems like they aren't, at least, and that's really clear in the way they talk about grazing and research in their papers, the way they define it, the things that they don't define that are important to ranchers. So what we came up with in this paper was like, okay, we know enough to be doing better. We know enough to tie grazing or aspects of grazing to drivers of change in the ecosystem. So we call these ecophysiology elements in the paper, and we outlined 5. So impacts of grazing on things like canopy cover, input allocation, input quality, plant diversity, and productivity. These are the main kind of movers and shakers in terms of how we change soil carbon in any ecosystem, and also the things that grazing impacts most directly, because soil carbon accrual from grazing is actually a very indirect process. It's the impacts of the grazing on the plants and then the plants on the soil that forms the loop. And then we connected all those impacts of grazing on ecophysiology elements to downstream pathways of soil carbon accrual. And that's the kind of mound palm focus on the bottom of that main figure.
Mm-hmm.
And the other thing I really tried to do was think about, we can't just say grazing as an umbrella term. What is grazing? And that depends on where you are. It depends on the climate, the kind of traditions that ranchers hold in any region. It depends on your scale. And so, like, what are the main metrics of grazing that ranchers, when they're thinking about moving their animals, for example, what are they thinking about? And so I came up with 4 what I call grazing management levers. And so that's grazing intensity. And I define that really carefully in the paper to mean the amount of forage that's utilized or defoliated.
Mm-hmm.
Grazing duration, so like how long are the animals on a pasture, or how long is any grazing event? Frequency, so how often do they come back to the same pasture to regraze? And timing, so that's the timing of when they come into a pasture or are grazing, which will also depend on where you are. So for example, in Colorado, Wyoming, we really only have a summer-fall grazing season. And in the Southeast, where most of our grazing literature has come from, you can graze year-round. So that's kind of what I was trying to get at timing.
Mm-hmm. Have you seen Alan Savory's TED Talk? There's a set of before and after photos in that TED Talk that show the transformation that's possible. And this particular set of photos are in Zimbabwe. It's totally barren land. And then just 3 or 4 years later, after managing holistically, the grasses are tall, head-high perennials. It's an incredible transformation. And there's a chance that you can go see this in person. We've got an upcoming Savory journey to go visit this site. This is the Dimongombe Conservancy. It's in Victoria Falls, Zimbabwe. It's Alan Savory's home. It's the birthplace of holistic management. It's the first ever Savory hub. We're running a trip in January of 2026. We're going to have a group of about 6 to 12 people going, and we've teamed up with the Africa Center for Holistic Management, and we're giving away one of these slots on the trip for free. If you want to get in on this, we've got a giveaway happening in celebration of Earth Day. There's 3 different ways to enter. Basically, you can donate to the Savory Institute, support our global mission regenerating grasslands, or you can support the local efforts that are happening at the Africa Center for Holistic Management over there at Dimagombe. The choice is yours. There's 3 ways to enter, 3 entries maximum per person. One lucky winner will be drawn to win this trip, which is valued at $4,300. Entries are open now. Get your entries in between now and May 15th when the contest closes, and then we'll select the winner. Airfare is not included. Terms and conditions apply. All the details are available on the website, which is savory.global/Earth Day giveaway. That is savory.global/Earth-Day-giveaway. We'll also link it here below the episode. We'll see you in Zim.
I mean, it's incredible to see what has previously existed in papers, which is mainly things looking at animal units or stock density and, realizing the limitations of that, to then have something come out where timing, intensity, duration, frequency are all being considered. I mean, it's almost like you've spent a lot of time with holistic managers and you understand variables that they're actually considering on a
That's
day-to-day
right.
basis, and they're trying to manipulate, to get the best outcomes on their land and with the performance of their animals. So I
Mhm.
love to see it. And then you framed all of this in 3 different categories of how undergrazing affects those ecophysiology elements, which then leads to the soil biogeochemistry pieces, and then optimal grazing, and then overgrazing. So you kind of
Mhm.
look at things in that lens through, undergrazing, overgrazing, and then in the middle, optimal. And actually, I have a printout of that
There
really
it is. Yep.
chart, which I think is just absolutely fantastic. If people are watching the video, they can see this. But essentially, what we're looking at here is over here is, the U-shaped curve to look at. This is the productivity that you're getting from undergrazing. Then what you're defining is optimal grazing or holistic management, amp grazing, however you're defining it, and then
Mhm.
overgrazing. And then how that affects the plant communities. These are the ecophysiology elements that you've defined. And then these different shades of brown is a cool visual looking at the different organic matter fractions. So I love this. I think this is super helpful and will hopefully inform future research for others that are studying soil dynamics with grazing. Is that the ultimate hope here? Is you're trying to set the stage and say, all right, guys, we can do better. And to do better, here's a framework that will allow you to do so.
Yeah, that is absolutely what the hope was, and the fact that so many people are viewing this figure and reading it and, like, really getting something out of it, I think I've never been happier as a researcher. That's exactly what I wanted for this paper is to be like, "Hey, guys, we can do better. Here's the things I think we need to be considering." And a lot of these things we need to be thinking much more critically about. Like, for example, if we want to really understand how certain kinds of grazing are driving ecosystem outcomes like soil carbon accrual, you've got to think a lot more carefully about what grazing means. Like, what is it about the grazing? Is it the frequency, timing, duration, whatever?
Mhm.
Um, and I think that it's catching on a little bit. I mean, it'll take some time to really see the fruits of this labor because grazing and soil carbon work takes time, but the fact that so many people are talking about it, I think is the right first step, and I'm, like, so thrilled and ecstatic. Also, I wanna give a shout out to Erica Patterson, who is she's a PhD student that works with me at Colorado State University, in rangeland soil biogeochemistry, but she is an excellent graphic illustrator. So we developed this figure together, but she's the one that executed and made it as beautiful as it is and as clear as it is, and I would be absolutely lost without her in my life to, like, bring these things to life with color, and she did an excellent job.
Yeah, I might have to tap her for some communications pieces on Savory. So
Absolutely. Yeah,
great
yeah.
work.
She does that as a bit of a side hustle, and she's absolutely excellent, so please reach out.
Love it. Well, let's get into those 3 different categories of undergrazing, overgrazing, and optimal grazing.
Mhm.
And speak to some of the mechanisms that are at play that are affecting, for example, what's the difference between overgrazing and undergrazing as it relates to the different eco physiology elements, and then how that affects soil carbon accrual? Can you just like run us through the different categories and, mechanistically what's happening?
For sure. So we define these broad categories of grazing because they're applicable in every kind of grazing situation. In every region and every climate, you can have an under optimal and overgrazed scenario. And depending on where you are, that could look differently. But the point was to illustrate like that there are end caps on over and under grazing scenarios that are not ideal in any case. And there's a way to graze in any climate, in any region, that can optimize for these things that we want to see, like soil carbon accrual. So, in an undergrazing scenario, this one was probably the most fun for me to develop because we hear all the time about overgrazing, right? Like it's a really obvious negative in any ecosystem. What I feel like is more misunderstood is undergrazing. And so we see this happening in like the BLM, US Forest Service. Their strategy to declining range condition is to reduce AUMs or to pull permits off of entire allotments. And the working assumption for many people, for many years, for many organizations, is that just removing ruminants from grazing on these historically grazed landscapes will cause that system to recover, regenerate, whatever. And that is often not the case
Mhm.
for a couple of reasons. One is, so for example, if you're in a subhumid climate like the Southeast, um, these are not like typically what we think of as historical grazing lands, but there still are some native grasslands in the Southeast. And if you remove grazing animals from these landscapes, there's a couple of things that happen. One is you get canopy closure. So because there's no defoliation from grazing ruminants, the plants will just grow and grow and grow until they're really tall, and then they'll start to shade in on themselves. Once that happens, you actually shade all of that undergrowth that would have otherwise had the opportunity to come up. And so you can actually reduce net primary productivity and total biomass in that way, just because you're reducing the amount of light capture that the plants underneath would have otherwise gotten if you had some, excuse me, defoliation happening.
Mhm.
The other thing that can happen is plants grow and grow and grow and grow, and then they start to lignify. They start to undergo a different kind of growth where they're dedicating more energy, for example, to setting seed. And that's where you start to see more brown plants. The
Mhm.
carbon to nitrogen ratio shoots up, and then it becomes a less yummy kind of soil input, less likely to form that mineral associated organic matter fraction. So, in that way, those are just a couple of examples um, of how undergrazing can actually hinder any ecosystem from accruing the amount of soil carbon that it otherwise could have if it would have been grazed in a more optimal way.
Mm.
Um, the overgrazing is much more, I think, easily conceptualized. So, if you're chronically defoliating an ecosystem, if you've got too many animals or maybe even too few animals for too long, they're going to keep coming back and eating the same things over and over and over, the kind of yummier plants among the pasture. And over time, the plants are going to be like, okay, well, this sucks. I'm going to die now. Um, and they will. And that's part of what we see in overgrazing. It's really obvious in terms of increasing amount of bare ground or shifting plant community composition toward more invasive species, which they strategically grow in less optimal scenarios. And both of those things can also hinder your soil carbon accrual. If you're eating too much of those plants, you're going to hinder your net primary productivity. You're going to produce less biomass, and you're also going to expose your soil to, swinging temperatures and things that make them just a lot less able to hang on to the carbon that they already had. So those are the kind of two end cap scenarios that we defined.
So in that overgrazing scenario, because there is increased bare ground and less canopy cover and less basal cover, I guess, as well, that increased exposure of that bare ground there's oxidation that's essentially happening, and that oxidation then is releasing carbon into the atmosphere. Is that correct?
Yeah, that's right. And you can think of it in a couple of other ways too. So if you don't have an active plant growing on top of soil, um, there's then not a lot of root structure to maintain the soil or prevent it from being eroding. Um, you also can drive your microbial community to be a lot less diverse and functional and productive because just fewer microbes are able to live in such inhospitable environments with like really high temperatures, for example, when they're not covered by plants. So part of it too is like, preventing soil erosion by maintaining living plant cover. And the other is like by having your soil covered, you're also selecting for a much more diverse and productive microbial community, which are really the movers and shakers in terms of soil carbon.
Mm. I had a question that just came
Mhm.
up, and I remembered I wanted to ask it when we were talking about your amping up soil carbon paper, and I forgot to
Yep.
ask it. It is
Okay.
not relevant to this ruminating on soil carbon paper as much, but in that, in your study on California rangelands, you did over 1,400 samples in the
Mm.
study, and this may open a can of worms. What is the correct number of soil samples to take when you're on a ranch?
Are you ready for the most infuriating answer ever?
It
It
depends.
depends. Yeah. It depends. I get this question all the time, all the time. And oh gosh, this has been like one of those questions it's just become like so central to my work. And I think so we try to answer this question in an earlier paper. I think this was, oh gosh, 2023. It's like valid inferences on soil carbon or something. The premise of this whole thing is that rangeland systems are just really variable. They have a lot of what we call spatial heterogeneity. So soil carbon from uh, one point to the next, even in really close together distances, can be very different because, I mean, think about all the ways in which rangelands exist. They often have diverse plant communities, some of them really discontinuous plant communities. So think of like a Colorado sagebrush steppe. You might have a sagebrush and then lots of bare ground and then maybe some western wheatgrass, but it's in this kind of really discontinuous mosaic. Rangelands are also typically rocky, they are slopey. All the things that make them not good to be used for croplands also contributes to them being really variable in terms of their soil carbon. When that is the case, it's almost like detecting and quantifying soil carbon change from something like grazing management is like finding a needle in a haystack. If you've got a bunch of background noise, a bunch of spatial heterogeneity, finding this little minute change that is really important and impactful becomes really difficult. The only way you're able to overcome that is by taking a ton of samples. So you kind of start to able to kind of collapse some of that background noise and be able to find the differences that you're really looking for. And so that's become such a crux of my work is trying to optimize the ways in which we are able to detect and quantify change. Because I think one major problem I see in the literature as it exists right now is that if you were to Google grazing soil carbon, you're going to find a lot of studies that say no change was detected or that
Mhm.
grazing was not, it did not impact soil carbon in a meaningful way. And I would wager that 90% of those studies, it's not that there wasn't a difference, it's that they collected too few samples to be able to tell the difference. And
When you
that is
how
a
would you define
sorry.
too few samples? Could you give an example of, like, the number of samples that are typically, collected in, typical research and why that might not be enough?
Yeah, I mean, the number varies so widely, and, like, I'm thinking back to my very first ag statistics class where, like, the rule of thumb is 30 samples.
Okay.
I don't know how common exactly that number is, but when I say too few, what I mean is too few to meet what we call statistical power. And statistical power is like, how likely are you to detect a change if it exists? And the number of samples it takes to reach that power threshold depends on your system. So for example, if I was trying to measure soil carbon change on a 1,000-acre ranch, that's going to take a lot of samples versus if I was trying to detect change in a 10 by 10 plot.
Right.
So it depends. It depends a lot on your system, how variable it is, how much change you expect over time. So for example, if you're like part of the Marin Carbon Project and you're spraying a metric F ton of compost on a system, that change is probably going to be big and it'll be a lot easier to detect. So you need fewer samples to be able to tell the difference from the noise versus in a grazing system, even with amp grazing and semi-arid systems, the change is low and slow over time. So you need a ton of samples to really be able to detect that difference. And actually, as part of that valid inferences paper, my co-author, Jake Spertus, who is I think they should be finishing up their PhD in statistics at Berkeley now, developed a web app to make it really easy to know what that number of samples is. So it's linked in that paper. The intention is to try and make it easier for people to take the correct number of samples versus just continuing to take too few samples and then misinterpreting non-detection for no change.
Interesting. I'll definitely grab that from the paper and put that in the show notes because I definitely want to check that out personally.
Sure.
I think this discussion on the number of samples to take, I think we could probably also get into the different technologies that are being used for soil carbon analysis and that sort of stuff. But it makes me wonder, what is the difference between research that is conducted for academic purposes versus a rancher who may be curious what their carbon levels are? Maybe they're interested in carbon markets. I know that would be a different play and have a different set of standards. But the type of research that you do and the type of methods and protocols that you follow, how realistic would it be for, your typical rancher to conduct a similar level study on their soils? Is it commercially available and cost effective, or for a typical rancher, should they be considering other methods?
Ooh, that is the question of the last couple of years. And in my honest to God opinion, it's not feasible and it's not cost effective at all. To do it right,
To do it on
it
your own.
isn't. To do it in general, I mean, even in research settings, in the work I'm currently doing, the amount of money and activation and energy it takes to like really take as many samples as you need to be able to detect change with some degree of certainty is astonishing. Now, in a carbon market setting, this is where I start to struggle because the carbon market is meant to do two things. One is act as a lever for climate change mitigation, and the other is to reward producers who are doing the right thing and having an impact on soil carbon. Now, if it was just the latter, if you were just looking for a mechanism to reward ranchers who are doing good things for their soil, absolutely. But because the entire mechanism of carbon markets is also meant to do the former, mitigate climate change, you need to be very certain that any amount of offset that you're generating is tied directly to soil carbon that's been sequestered and is going to hang out there for a while. That's where you really start to get the rubber meeting the road, because just quantifying soil carbon at one point in time is actually relatively easy. Detecting the change, which is where the credit comes from, the drawdown, that's where you need all the samples and all the good processing and good analytical techniques. And so I never want to sound like I'm losing the forest for the trees, or that like my academic goal of perfectionism is getting in the way of ranchers being paid. I don't want that. What I do want is for ranchers to get paid and it also to have standing in terms of climate change mitigation. And that's where that number of samples becomes really important. And it also is where I'm starting to become really hesitant, because I know that in order to do that right, it takes more samples than I've seen almost any carbon market application have. And so what I think is happening is it's kind of the wild, wild west right now in the carbon market space. Now, I do think there are improvements being made and there are good actors out there, but I know that the cost of doing it right and accurately is more expensive than the profit that anyone stands to make off of a carbon offset. And because I know that that economic framework doesn't make sense, there are two ways then to make it work. One is just to not do it right, take fewer samples and have a way more uncertain number, but in a way that's cost effective, or not do it at all. And what we're doing is the former. That's what I'm seeing happen in the carbon market space.
So since it sounds like with carbon markets, there's some weaknesses in some of the methodologies being used in the carbon markets, and that is likely because carbon as the sole metric that is being tracked has variability, requires high, sample size, et cetera. It needs to be statistically powered. Would expanding the scope of how incentives are provided to producers, such as looking at not just carbon, but also looking at things like biodiversity and some of the above ground dynamics, on rangelands or, water dynamics, would bringing in more variables that perhaps are a little more solid in terms of their measurement and easy to measure, would that help improve the trustworthiness of credits?
Maybe. And those markets certainly are developing as we speak. They're called ecosystem service markets, and they exist for things like biodiversity, water. I think there are some. And I think they're great because these are all ecosystem services that are real and valuable. But again, their tie to climate change mitigation is a little more nebulous than soil carbon sequestration is. And so I think that's why soil carbon was like the leader in terms of market development in the space. But in terms of the other things being rewarded on ranches that are doing the right thing, I'm all for it. But it turns out biodiversity is actually not as straightforward to measure either. I know less about it, but I hear from the folks that work on it that it's not it's not as rainbows and butterflies as it seems. In any case, I think the other hesitation I have in carbon markets is that in order for it to be a functioning market, you need to meet a couple of criteria. One of those is called additionality, which means that you need to have some certainty that this practice change is new and that soil carbon wouldn't have otherwise been accrued without this practice change. And what that means is that you need to be onboarding ranchers that are doing new practices all the time. And so you're leaving out a really crucial population of regenerative ranchers, which are the OG ones, the ones that have been training other folks, the ranching for profit folks, the HM practitioners and educators that have been after this for a long time. And these are people that deserve, in my opinion, even more credit, even more reward for the work that they've done, especially since they were doing it so early on. They're completely out of the carbon market, which
Because
breaks
they're
my heart a
coming
little bit.
and you're saying that it's difficult for them to enter a carbon market because you need to have a baseline measurement. And if someone has been practicing holistic management for 2 decades, their baseline measurement times zero, they're already going to be really high up there in terms of their carbon content of their soil. And so any accrual is going to be minimal at that point because there's not as much of a delta for them to overcome in terms of changing practices and management methods.
Yeah, that's true, but that's actually not the additionality criteria. The additionality criteria is saying that they're already doing HM. They're not doing new HM. They haven't started HM just now. So that soil carbon accrual is already happening. So in order for them, for example, to be eligible for a carbon market program, they might need to do something else like range seeding or compost application or something. It's got to be something additional and different than what they've already been doing to be
Yeah.
eligible.
Do you see advances in technology changing anything as it relates to, I mean, not just carbon markets? I know that's where there's a lot of discussion because that's where there's a lot of money to be made. And I think that's where there's also an opportunity for a lot of shady players to come in and for bad practices to give this whole space a bad name. So we
Right.
really need to be careful about carbon markets and claims that are being made there. But just
Mhm.
broadly speaking, in terms of advances in technology that could help for improved quality of soil science in general. Are there any things that you're seeing that are exciting? I know there's like handheld devices that look at like visible and near infrared as a means
Mhm.
of measuring soil carbon. Where do you see technology coming into this, not just now, but also into the near future?
Yeah, absolutely. I see a lot of potential in technological developments happening as we speak. And spectroscopy, so the thing that you were alluding to with near and mid infrared, these are technologies that are meant to be able to predict quantitative soil features based on um, things like coloration.
Hmm.
And so, what spectral methods do is we can scan a soil, it'll read things based off of it or based off of its color, for example, and then it'll allow you to predict different things like texture, mineralogy, and soil carbon as one metric. And I see a lot of potential there because it's so cheap and well, I don't wanna say easier to do, and there are different ways of doing it, like, I've seen folks, like you were mentioning, develop these handheld, scanners that you can just, like, take your soil sample, scan it, and then get a read. There are
Hmm.
also companies like Yardstick that have developed, probes that are meant to do this, so, instead of taking a destructive soil sample out of the ground, you kinda drill this probe into the ground, which takes readings, and then in our lab here at Colorado State in the Soil Innovation Lab, we use a type of technology called FTIR. It's a mid infrared, and but it still requires the kind of destructive soil sample. And I'm seeing a lot of promise there. Now, in range systems, you still have a couple of unique challenges. Like you need to build an entirely calibrated spectral library that is relevant to your system. So it's not as easy as it seems, but I see a lot of potential, especially because of the cost savings that it presents. But I don't think we're there. We're not there quite yet, in my full honest opinion.
What about satellite technology? You hear a lot of folks
Mm.
talking about, hey, let's look at NDVI to measure the productivity, the photosynthetic activity that's happening on a landscape, and let's use that to extrapolate what's happening in the soil dynamics. Where does satellite imagery come into all of this?
This is one I struggle a lot more with to see the potential utility and accuracy for because remote sensing is really, really great for a lot of things like estimating productivity, NPP, which are all important information, especially if you want to understand like the potential for soil carbon accrual. What I've not seen the capability for those technologies to do quite yet is estimate soil carbon directly because you're inferring things about soil based on things you can see from space, like plant cover, for example. Or if you want to infer something about soil directly, you need to be able to see the soil from space. You need bare ground, which in cropping systems is easy because you've got to harvest those plants at some point. In conventional systems, you're tilling it. So you can physically see the soil from space. That is not the case in lots of grazing systems. Now, you do have, systems that are more inclined for bare ground and semi-arid and arid places, but I've not seen anything that seems especially convincing at this point, especially knowing I'm an experimentalist. Like I go on the ground, collect my soil samples. That's my bread and butter. And I know how variable soil can be from 1 meter to the next when you physically pull the soil out of the ground. So I think my like actual on the ground experience combined with my I think understanding of the utility of remote sensing and those like NDVI technologies makes me a lot more skeptical.
Mhm. Is there an opportunity at some point to wed the two in terms of using remote sensing, but then ground truthing it with actual soil samples and doing that, powering a study with enough samples so that you can get some sort of predictive modeling that has some sort of statistical significance there?
Absolutely. There are companies that are trying to do just that. So Perennial is a company that's trying to do that. Um, and they they've built models based on machine learning, which are intended to do just that, and then they feed it or spike it with soil samples that they physically take. I I don't know a ton about where that technology and where their machine learning models sit right now in terms of range systems. I think for croplands, it was doing pretty good, but it's been a while since I've checked into it. But I know that people are certainly trying.
Hmm. And with these technologies, I mean, you just mentioned croplands. Going back to the discussion of a homogeneous landscape being much easier to read, you need less samples, it's much more predictive versus rangelands, which are much more spatially heterogeneous. My God, I can't talk today. Come on,
It's a
man.
hard word. It's a hard word for anyone.
It's
No, 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 it's not
there's
on here.
more of a mosaic. There's a lot more going
Yeah,
on. They're more complex.
that's
Um,
right.
it's not as easy to do these things on rangelands as they are in croplands. And
Hmm.
similarly, it's easier in croplands to look at a single practice change and say, okay, you're doing this across your 10,000 acres. You're planting corn and
Yep,
soybeans, and now you are doing no-till and cover crops. Let's measure the difference between this practice change. It's a lot harder for someone who's going from, say, set stock grazing operation to holistic planned grazing and monitoring the changes there because it's highly dynamic and there's so many
that's
more
right.
variables that are, being modified there.
Yeah, I think that, and that is absolutely what has contributed to our lack of research on grazing systems that have that key component of adaptivity. And honestly, that is at least where I sit now in my understanding of grazing and soil carbon, it's adaptivity and the dynamism that is key. Now, the number of rotations, the amount of duration, the timing, like there is no hard and fast rule for when and how to do all of those things. And I think the key common denominator among the ranches that I've sampled on that I've seen make real, measurable, impactful changes on their ecosystems have been because they make decisions about their grazing management adaptively and holistically. So I do really believe that it comes down to that decision making framework and practitioners, grazers being able to go out onto their ranches and say, I maybe took too much off this time. I'll move these animals out of this pasture a little faster next time. Or it's a little dry outside right now. We haven't gotten as much rain as I expected. And so I don't have as much regrowth in this pasture as I wanted. So I'm going to take them to this other pasture instead. Or, I can see some seedlings of some cool perennials that I really want to focus on maintaining. So maybe I'm going to graze this a little lighter, or maybe I'll wait till these plants have set seed, for
Hmm.
example. That's the kind of adaptive decision making that I think is the key to all of the places where I'm seeing soil carbon actually being accrued from grazing. It's less about the take half, leave half. It's less about the rules of thumb and more about like empowering these folks as citizen scientists to make decisions based on things that they can see.
Hmm. And I
And
think
that's
that's
also what makes it impossible to, well, not impossible, and challenging to do research on.
Yeah, yeah, absolutely. It's a blessing and a curse. Um, and all these different dynamics and variables and questions that ranchers are asking on a day-to-day basis, and how they are proactively adapting to the changing conditions ahead of them, and planning accordingly and replanning. I think this is all laid out very well in the other paper of yours, which I don't know if we're going to have time to get into today, but it's I think one that the listener should definitely go check out. The paper is called "Holistic Management Shifts Ranchers' Mental Models for Successful Adaptive Grazing." And what's different about this paper is that it's not soil science; it's more the social science. You went out and conducted interviews with producers to figure out how they work, what their motivations are, how they view their landscape and their role in it. And you developed some core themes. I know that we're running up on time here, but do you want to give just like a quick, brief synopsis of what you found there, and why that was important to put out?
Yeah. So this work was actually the first thing I did as part of my dissertation when I was designing um, the kind of experimental setup for the paper that just came out. What I actually started doing was going out and talking to ranchers first. That was the first thing I did. Um, And that turned into this paper because I actually took those interviews and was like, there's actually some really rich stuff here that's useful beyond just like really understanding their grazing management for this AMP grazing soil carbon paper. Like there's something here to all the things that ranchers are telling me. And so actually I had some training prior in social science. And so what I did is I took these interviews and I coded them through an iterative process to try and pull out some emergent themes. Like, where are the consistencies? Where are the differences? What new information can we glean from these ranchers? And so I came up with a set of themes, but I think really the crux of this paper was that it seems like holistic management in this kind of decision-making framework that comes from holistic management helps create entirely new mental models for ranchers and practitioners to operationalize AMP grazing. So it creates a kind of closed feedback loop in terms of their decision making, which makes them able to make decisions adaptively, think about how to change their grazing management in the future, maybe even preempt ways to change their grazing based on things like drought and recovery. Part of that is just like the physical boots on the ground impetus of getting out there every day and laying eyes on it. And the other is like giving them the tools with which to make improved decisions about their grazing. And so it's this like complete decision-making framework, which makes them more able to do things adaptively, is at the center of all this. The other thing I really wanted to try and understand is like what drives ranchers to change their grazing management from whatever they were doing before into something like AMP HM. And I was hoping that was going to be a really easy answer, right? Like, oh, we were about to go bankrupt. And so boom, we decided to do this thing. But it turns out, and actually now in hindsight is completely unsurprising, that there is not like a core set of themes that drives ranchers to do this thing. It's really like, one rancher I remember in particular had a daughter that went to college and majored in environmental science and was coming back and telling her dad about all these things she was learning, and he was intrigued. Right. There are some ranchers that were plagued by, fear of bankruptcy, and they were like, started learning about HM as a bit of a Hail Mary. There are some ranchers that have been doing this all along because, early on in the popularity of holistic management, it just made sense to them. Something clicked early. And so there isn't really like one driver that I feel like I can hang on to and tell people like, oh, this is the thing. And that's, I think, also brings me back around, and maybe in one final comment about carbon markets, is that knowing that there's this diversity of reasons why ranchers choose to shift to AMP or holistic management also tells me that there isn't a clear payment structure that's going to make this worthwhile for folks. This isn't a simple practice shift like reduced tillage or cover cropping. It's not nearly as straightforward. The shift to AMP HM, as this paper talks about, is a complete 180 on decision making, on mental models. It's like a complete destruction and remaking of the way ranchers view their ranches, their ecosystem services, and their interaction with them and their animals. That is not something that I see being directly applicable to a payment structure in this way, because I don't think I could look at any of the AMP grazers that I've worked with and been like, would you have done this for $10 an acre when you got started? And they would look at me like I was nuts. And so maybe that's enough for some people to get started, like the opportunity to make more money, an additional income stream. Maybe that's enough for some folks. And for those folks, absolutely. I just don't know how many that actually is.
There is, I think what's clear from this episode is there is so much nuance and complexity in soil science and understanding the motivations for how ranchers make decisions and everything that goes into it, whether it be for carbon markets or research academic purposes. There is just a lot of nuance. And I would say thank you, Dr. Stanley, for helping us weed through some of this and make some sense of it all. I know this was very enlightening for me. I know we're running up on time and you got to go, but do you have any parting words that you'd like to leave for our audience, or, point them to where you exist on the internet and where they can find more about you?
Yeah, absolutely. My internet presence is a bit in flux right now. I'm transitioning kind of more off Twitter and onto Blue Sky. So I'd say I'm much more active right now on Blue Sky, but I also have a website. I'm based at Colorado State University in the Soil Innovation Lab, led by Dr. Francesca Catrufo. So I interact a lot with ranchers, with folks like Bobby Yu and the Savory Institute, with other researchers, institutions. So if ever anybody has questions, I'm always available, either directly over email or more indirectly through platforms like Blue Sky. Always feel free to reach out, and I'm happy to chat and muddy the waters on all things grazing and soil carbon.
Yeah, wonderful. Well, we'll put links to all those places where you can find Dr. Stanley in the show notes. And just want to say thank you again for joining us today.
Yeah, thank you.
All right, have a good one.
This episode was edited by Claire Everson, and our theme music was composed and performed by Travis McNamara. Ruminations is a production of the Savory Institute, the Savory Foundation, and Land to Market. If you like this episode, please consider leaving us a 5-star review on Apple Podcast and subscribing to our YouTube channel, where you can find video versions of all episodes, plus other content. If you're looking for show notes, links to things mentioned in the episode, transcripts, sponsorship info, or if you'd like to even suggest a guest to come on the show, all of that can be found on our website at savory.global/podcast. And last but certainly not least, thank you to our committed and growing community of regenerating members whose monthly support allows Savory to produce this podcast and continue advancing holistic management all across the globe. If you're not yet a member, we welcome you to join us with open arms, and we would love to have you as part of our community. Just sign up at savory.global/member. Thanks for listening, and we will see you next time.